Hi everyone, my name is Max Maker, and in this episode I'm going to finish all of the electrics for the electric hydrofoil build. So as you've seen previously, I've got these batteries and these are going to go into this box right here. So I wanted to give it a little bit of a partition in the middle with this acrylic sheet that I cut on the bandsaw, because on the other side there will be the Arduino and lots of other electronic stuff to monitor everything and to keep the batteries safe. So to keep the batteries separated from the Arduino, I thought that would be a good idea. I added this little piece of acrylic, and gluing this in was a real challenge because it turned out nothing really sticks to polypropylene. So what I did was I roughed up the surface really good with a chisel. First I tried it like this, just with crisscross, but that wasn't good enough. And then I discovered if I just wiggle it back and forth, I get these little flakes. You see these flakes on the tip of the chisel, and most of that stuff stays on the box and gives the hot glue a really good mechanical grip. So the hot glue doesn't really stick to the polypropylene, it's just interlocked with these little fuzzy things. And it's not waterproof, it's just a partition, and I had to remove these grommets later on because there wasn't enough space to get the cables through. And while I was at it with the hot glue gun, I also added lots of foam to all the surfaces so the batteries are really cushioned, because I thought if I have a really heavy fall, I don't want any of these batteries to pierce, because that would be a really big explosion. I don't know if you have seen LiPos explode yet, but they do create a pretty big fireball. So the batteries fit in there quite nicely, and I also have space in the middle to add the big relay that's going to turn them off. And then I cut out this piece of plywood to mount everything to, and I created these slots so I can use Velcro straps to attach the batteries securely so they don't flop around. And just in that moment, Craig J actually sent me a parcel. They sent me this really cool router lift for free. I'm really grateful for that. It's super heavy and I couldn't wait to try it out. It's a bit overkill for this application, but I used a round over bit to give all the edges a nice round over. So again, this is just to make sure that there are no sharp corners that could pierce the batteries, because that would be a real disaster. And it worked really well. This is a really nice addition to my workshop. Thank you, Craig, for this. I think it's going to get quite a lot of use. So I've got these 4 batteries, and 2 of them are always going to be wired in series, and then those 2 will be added in parallel. And I wanted a convenient way to connect all these connectors to each other, so I created this little terminal block on my CAD software, and I printed this on my 3D printer. So there are going to be these XT90 sockets in there, and then I can just take the battery cables and plug them right in there, and I don't have to worry about the connections. Nothing can short out and everything will be secure in place. I expect that there will be quite a lot of testing with different props and foils, and all these variables can change, so things that don't have to change, I want them to be set in place and mounted everything down. So I also mounted this big relay because the batteries are going through this, and this relay comes from a forklift. I got a lot of suggestions from you guys for where to get a relay, and I found this one, and it's rated to I think 500 amps, so should be good enough for my batteries. And everything beyond this relay will be covered with XT150 plugs instead of XT90s. I will probably glue them in permanently with epoxy once everything is set. And now it's time to add some wires to this. So 2 of these connectors get connected in series. So here I'm connecting the plus and the minus terminal of 2 batteries, and then I've got 2 cables coming out, one positive, one negative, and they will then be connected in parallel to form this really big battery pack. But of course the juice first has to flow through this relay, so I'm attaching both the positive cables to one terminal of the relay with these crimp connectors. They're just super convenient. You crimp them together in your vise, because as you can see here, soldering these really big cables is not that easy. And I really had to apply this soldering iron for probably a minute or so to really get everything hot enough so it would flow on its own. But I'm happy with this, turned out okay, and we'll see if anything melts in the testing phase. And these 2 connectors on top of the relay, I was afraid that you could touch them and then get a shock, so I printed this little cover on a 3D printer. And all of these files are on my Patreon page, so if you're a Patreon you can download these. And I gave this a little bit of a spray paint to make it look pretty. And this is going to be a secure mounting place for this fuse holder, because I don't want anything to be flopping about, because if anything could go wrong, I don't want this to blow up. Am I overcautious? I don't know. You can let me know in the comments. And it was time to add some through holes. These are the first through holes for this case, for the battery cables, and then I've got a third one for the sensor cables. And on top I added 2 big buttons, and these are supposedly waterproof, and I really batted them in with a lot of silicone. And silicone doesn't stick to polypropylene either, but I just hope the compression will make it waterproof, and I also have some O-rings in there. There will be a little LCD display inside the board telling me all kinds of stats about what's going on with the motor and the temperatures, and obviously that needs a waterproof window, so I cut that on my CNC from polycarbonate, and the same cutout was also done on the electronics box. Since I already had the data, it's not a big deal to just let the CNC cut it. It's cleaner and easier, and I don't need to use a jigsaw. And I embedded everything with lots of silicone, and I screwed them down with the stainless steel screws. So that's pretty much it for the battery box. And I blacked this out so it's just a little bit neater. Next up is the box for the ESC, which is going to be inside this aluminium box, because it's also the heatsink for the ESC. It's going to get pretty hot, 120 amps at 50 volts, so it's a lot of power, and the bottom needs to be super flat, so I jigged it up on the CNC, so the ESC will have good contact with the bottom of this box. The first pass wasn't deep enough, so I gave it a second pass, and that made it nice and flat. I did have some low spots though, which are okay, because they're just, you see these little half moon shapes, they're just in tiny areas, and most of the contact surface is okay. And I sanded this a little bit smoother, and these 4 holes are going to mount the VSC to this box, so I need to drill them out. And while I was at it, I also drilled the rest of the holes for all the cables to go through and the sensors. So this box needs to be absolutely waterproof, and I just drilled a lot of holes to this. So all of these are getting waterproof connectors, and I really hope they stay waterproof, because I'm not really sure. Like, if one of them is faulty, then I'm ruining the VSC, which is like $300. As you can see, the bottom here is not flat at all. So I flattened this with sandpaper and then polished it. So I've got a good contact surface for the energy to dissipate into the aluminium housing. And I'm using this thermal paste, like you use on CPUs on computers, and I'm using really cheap stuff here. And I just want a thin layer to get rid of any air gaps, and then I screwed everything down, and these screws obviously need to be caulked as well with lots of silicone, and I used a lot of this stuff. And while I was at it, I also caulked all of these solder joints for the motor, and I slid some heat shrink tubing over this and a hot air gun, shrunk them down a bit and really squeezed out the silicone. And after that was dry, I added the second layer just for safety. Alright, so this is where we end up with this episode. We've got the batteries in here, we've got a big relay to shut everything off, we've got a fuse, we've got the waterproof connectors, and waterproof connectors here. This goes into the ESC, so this will be submerged in water up to about here, and the rest will overflow through the cables down back into the water. So this is nicely cooled. Got this cap that goes on top so I can stand on this. This is super solid. And we've got the 2 buttons. Got a little window for the display. This is waterproof, and we've got the motor connected. So still a long way to go. What's left to be done is adding the Arduino stuff in here for the remote control, having connections from the Arduino to the ESC, so this can turn on and off this motor. And we need the temperature sensors inside the motor and inside of here, and they need to be routed back to the Arduino as well. And of course I need some webbing to hold this down and to hold this down. But that's easy, and I think that I'm going to do that in the next episode. So some challenges I had with this build was really that the silicone doesn't stick to this. This was solved. This wasn't flat, but that was solved with the CNC machine, so I flattened this box. Could be a little bit difficult to fit these into the motor pod, so I need to make this really spacious. And with the motor pod, I plan to have water flow right against this wall right here, so it gets extra coolant from here. And this motor is supposed to be waterproof, so it will just be in the water like this. I hope you enjoyed this build. If you got any questions, just let me know. And if you would support me on Patreon, that would be really nice, because as you see, this costs quite a lot of money. And I'm just doing this for you basically, and obviously I want to write it too, but I wouldn't film it if it wasn't for you guys. So thank you for that. Oh, and I added 2 more screws here, because I thought a little bit more pressure there would be nice. So next up is the remote control and all of the electronics that go inside of it, and I hope this video inspired you to make something yourself today. My name is Max Maker, and I make all kinds of stuff.